Hello, my name is Muhammad Nafal Firdaus and I am from Group 2. Today we'll be presenting our project PLC Conveyor Belt Box Counting System. Our group has basically 6 people, all of us from mechanical engineering.
Hi, my name is Billy, and I'll be talking about the background of our project. Automation is increasingly vital in manufacturing, particularly for tasks like counting items on conveyor belts, where precision and efficiency are essential. Manual counting methods are slow and prone to errors, especially in high speed production settings. Automated counting systems, which integrate sensors and PLCs, offer reliable real time tracking and immediate response to changing conditions, thereby enhancing production accuracy and situational awareness. Our project demonstrates the shift from a manual to automated item monitoring by developing a PLC-based counting system. This emphasizes how automation improves accuracy, efficiency, and workflow management in modern manufacturing.
Assalamualaikum, my name is Hama and I will explain about the problem statement for our project. So in some manufacturing industries, operators they rely on manual counting to track the number of items on conveyor belt. This method is not only time consuming but it's also prone to some errors. Issues such as operator fatigue, restriction and fast production rate often lead to inaccurate counts. So this counting mistake can cause serious problems such as overloading the conveyor, late response when the system reaches its capacity, and unreliable production record. So therefore, there is a need for an automated solution that can detect items accurately, keep a consistent running count, and alert the operator when the system reaches a limit. Based on the problem identified, our project has 4 main objectives. Firstly, to design a PLC control counting system that uses a sensor to detect object on the conveyor. Secondly, to automatically increase the count every time an item passes the sensor. Thirdly, to activate an alarm once the count reaches 50, so operators are aware of the capacity limit. And lastly, to demonstrate the entire system using a PLC simulator with proper ladder logic to show how automation can replace manual counting. So through this objective, we aim to show how automation improves accuracy, safety and efficiency in a simple conveyor system.
Hello, so I will continue to present the visual aids. So, for the first picture, it shows that the loading and unloading area. So, it shows the starting point of material flow before boxes move onto the conveyor system. And it relates to our project because accurate counting begins as soon as boxes enter the line. And for the middle image, it is a conveyor belt system. So it highlights a typical industrial conveyor system and represents the core of our project and automated conveyor with sensors and PLC control. Is where the box detect, count, and overload logic happen in real time. And for the right image, the last image is warehouse storage. So it links to our second counter that tracks the total number of boxes removed to the warehouse, and it illustrates how the data we collect contributes to inventory visibility and throughout reporting. So as a summary, this visual show that the full journey from loading, conveyor processing and counting, warehouse storage, which is exactly what our PLC system automates. So next is theoretical consideration. So the first one is photoelectrical sensors. So what does photoelectric sensors do? So basically it detect object presence without physical contact, enter sensor that detects boxes entering the conveyor, and exit sensor detects boxes leaving toward warehouse. And also it enable real-time automated counting without manual intervention. So to highlight it, These sensors allow the system to count boxes in real time, and also this sensor remove the need for manual counting and ensures the process is fully automated and accurate.
The second theoretical consideration in the project are safety interlocks. For this system, safety interlocks play a crucial role in preventing dangerous or unintended actions. They ensure that certain functions can only operate under safe conditions, protecting both the equipment and the operator. The reset function is intentionally restricted so that it only works when the start button is off. This prevents the counter from being accidentally cleared while the conveyor is running, which helps maintain accurate tracking and avoids operational mistakes. When the system detects an overload, the PLC will trigger a combined safety response. The alarm activates to alert the operator, and at the same time, the conveyor motor is stopped immediately. This dual action helps prevent jams, mechanical strain, and unsafe buildup. Lastly, the system uses two counters working simultaneously. One tracks how many boxes are currently on the conveyor, and the other records total throughput to the warehouse. This dual counter approach provides real time visibility of both operations, ensuring accuracy without relying on manual counting.
My name is Ilyas and I will be presenting about the theoretical considerations on audible and visual indicators. Now, when the system reaches its maximum capacity of 50 boxes, an alarm turns on to notify the operator. The system also uses a status light to show what's happening in real time. And another indicator, which is called the item present light, will switch on whenever there's at least one box on the conveyor. Now, by combining both sound and light signals, the system ensures that the operators can quickly notice and react to any changes. So, moving on to application design, what our system do or what its purpose. Now, the sensors monitor boxes as they enter and exit the conveyor. The PLC updates the warehouse counters in real time automatically. When the count hits 50, the conveyor stops and an alarm sounds. An indicator light shows when the boxes are present on the line. Now, the reset buttons clear the counters with a built-in safety interlock. Overall, the system boosts accuracy, enhances safety, and eliminates manual counting. That is all for me. Thank you.
Hi, my name is Muhammad Afi Aikal, and I'll be presenting the circuit explanation. First, the start switch powers up the PLC system, initiating the process. Next, the enter sensor detects incoming boxes, which automatically increments the counter by 1. Simultaneously, the exit sensor detects leaving boxes. This triggers the counter to decrease by 1, while the warehouse counter increases by 1 to track the throughput. Throughout the operation, the PLC controls the conveyor motor based on safe conditions. Most importantly, if the box count reaches 50 or higher, the alarm turns on and the motor stops immediately for overload protection. For status monitoring, the item present lights turn on whenever the count is greater than 0. And finally, the reset button clears the counter, which we will have designed with a safety interlock to prevent accidental resets. To conclude our presentation, this project, PLC Conveyor Belt Box Counting System, is essential in especially the logistics industry. Hopefully, in the near future, our system, this conveyor belt box counting system, can be applied and realized in the industry. That is all from us. Thank you.